Alright, so let's do a start to finish practical application. And so I've been working with the bank account, and I'm going to start to finish and do all the implementation in this video. So I'm going to go into my labs package, and I'm going to create a new class and call this bank account app. Okay, we'll give it the main. Okay, so I'm going to go here, have my class bank account. Okay, and again, what are some properties? Properties of bank account would be something like we have string account number, we have string routing number, string name, string SSN. Right, so these are the properties of the user, but we also have string, actually this would be double, balance. And we also give this a string ID. Okay, actually this would be an int, this int ID. Okay, now we want to use encapsulation here, so we're going to make these all private. So private. Okay, so encapsulation will ensure that the client doesn't have access to these variables except through the methods that we provide them. Okay, so the first thing we want to do is then set our getters and setters. So we want to say, actually before we do that, let's do our constructors. Okay, so let's have our constructor say we have our public bank account, right? So this is our class name, so we have our constructor be the same name as the class, and we're going to take, let's say, their social security number. So we'll say we want to say string social security number. Okay, now we'll use the social security number to generate an account number. So couple of things here. So our account number, we will define, our account number will be, this is a combination of the ID plus a random, say 2-digit number, plus the first 2 of the social security number. Okay, so we'll show you how this will work. Okay, so our social security number is good, so we can actually, when we create a new account, we'll say new account created, just so we have an idea, so we're sure that this is actually occurring. In fact, let's run our application right now. We'll say bank account ACC1 equals new bank account. We need to pass a social security number, which is going to be, let's see, it's like 3 digits, 2 digits, and then 4 digits. There we go. Okay. Okay, there we go. So now we run. New account created. Okay. So once we call the constructor, what we want to do now is we want to have this ID. So this ID is going to be internal ID. In other words, the user, the account holder, is going to have their account number, but we as the bank are going to have our own internal ID processing system that will have a separate way to identify people with. So we're going to have an ID. So if we want to have a unique ID for each person, for each new account, we want this to be static, because we want this property to belong to the class, not a particular person. Okay, so how's this going to look? So every time we create a new account, let's initialize this, say to 101. Okay, we want to increment ID plus plus. This is ID plus plus. There we go. And we'll start at 1000 since we're gonna increment after the first one. Okay, so let's show how this is gonna work. So every time I hit ID or create a new account, right? We'll see how this is incremented each time. So I'm going to run this. So I'm creating 3 accounts, so I'm going to see ID increment each time. There you go, 101, 102, 103. Okay, that's because, again, this value, this variable is staying with the class, not the object, right? Okay, so here we go. Okay, so this is our own internal ID. So once we create the ID, now what we want to do is generate the account number. So I'm going to make this not accessible to the client because I don't want the client to be able to set the account number. I want the account number to be automatically generated by the backend. So I'm going to say private set account number. Okay, so once we call, this is private void. Once we create a new bank account, and we increment the ID, now we're going to call set account number. And I'm going to pass, actually I don't need to pass anything. Okay. Okay, so let's see here. When we set the account number is going to be, so account number is going to equal, it's the ID. We're going to concatenate a random 2-digit number. How do we calculate a random 2-digit number? Well, we can use a function here. We'll say integer random equals math dot random. Okay, now when we do math dot random, it will generate a value between 0 and 1. So if we want to have a 2-digit number, then what we want to do is multiply by 100. Or actually not 100. We multiply by 10. Okay, now that's going to return a double, so we actually need to cast it as an integer. Okay, so before we move on, let's make sure we print out random. And now we can run this here, make sure we see a new account created, and there we go. Let's run this again. Okay, I guess this should be 100. There we go. There's our 2-digit number. Okay, so we have our 2-digit number. So we want our account number then to equal again the ID. Then we're going to concatenate. We're going to concatenate the random. And then we're going to have the first 2 digits of the Social Security number. Okay, so the Social Security number is we're going to set when we create a new account. So we're going to say Social Security number equals, we're going to say this dot SSN equals SSN, right? So we're setting the value of the instance variable SSN equal to the local variable SSN that's coming in right here. Now what we want to have here is that we want to see the first 2 of the Social Security numbers. So we're going to do substring, or we're going to do SSN dot substring, begin at 0 and end at 2, actually end at 1. Okay, now let's print account number. Okay, now we run this here. There we go. We have 1001, a random number of 65, and looks like we do want this to be 2. There we go. 1001 4246. So this is your account number. So we're going to say your account number. So there we go. Okay, very good. So now I can delete new account created, and let's create just a couple more accounts. Right. So we're going to say account 2, account 3, and let's have these be again random few digits here. And when we execute this 1, 2, and 3, this function will automatically get called because we're calling it from our constructor. Here you go, 101, 102, 103, random 2-digit number, and the first 2 of the Social Security number. Okay, so this might be some way that you would generate a unique account number, right? There's multiple ways, but we have a static ID. We have the something that depends on the user, and then we have a random number. So there's a combination here of what we're using. So this is somewhat realistic in terms of course, what we might see in the real world. Okay, next thing is routing number, right? Routing number is also going to be static. We talked about this in the lab because the routing number is going to be not unique to each object, but it's going to be the case for all classes or all objects, so or all accounts. So we can say our routing number is going to be, 0045400, something like that, right? I just made that up. Okay, so if we want this routing number again to not change, we can have this be private, static, and final. So final is basically a constant within Java, so we can't change this routing number. Okay. Okay, so we have our ID, we have our account number, we have our name. So if we want our name to be set, right, we want to say, okay, public void, we want to set name. Okay, we're going to take string name. Okay, how do we incorporate this encapsulation? We're going to say this dot name, so the instance variable is going to equal the local variable, and we also want to do public. We want to return string get name, and we're not going to take any parameter, and we're going to return our name, the instance variable. Okay. Alright, so we have taken care of that. So let's just say again here acc1 dot, again, so no variables are available to us, only the green dots are methods, so there's no blue, which is variables. We want to set name, and this we want to say is, again, how about Jim? And then we can print, say, acc1 dot get name. There we go. Again, these are then tied to our account1 object. So there we go, account1 Jim. Okay, so we have our getters and setters here, and here we go. What else do we want to do? We have our SSN, which is actually not going to be accessible at all. We don't need a getter and setter because we take it when we get the constructor. Let's see. The last thing is, let's actually implement our balance. So we want to say, well, again, we'll just work with account1. First of all, let's say when we have a new account, we need to have some kind of initial deposit, right? So we are going to have this be something like 1,000. Say there's a $1,000 deposit minimum, right? 2,500. Okay, so this is flagging an error because there's no constructor that handles a string and a double or a number. So we need to modify our constructor to also take a double value. So we're going to say double init deposit, and because this could be anything, right? This could be something like this. And then we're going to say our balance. Actually, we don't need to initialize balance because our initial deposit will be our balance. Balance equals init deposit. Right? Okay. So when we set our account number, let's see here. Okay, no, this is good. Okay, so what are the methods now we want to do? We want methods like public pay bill, and then we're going to have a double amount, right? This is void. We want something like public void make deposit double amount. Okay, just for example here, and then we're going to say the balance then is going to equal balance minus the amount, and then when we make a deposit, of course it's the opposite. Balance equals balance plus amount. Okay. Okay. Very good. So let's see here. So if we want to say account1 dot make deposit, we're going to deposit say 500. We want to do withdraw. Let's do another deposit, say 600, and we do a withdraw. This is what pay bill, right? Of 1,000. Okay. So if we run this, we're not going to see anything here, right? Because we didn't tell it to print anything. So after each let's say after each transaction, we're going to do public show balance, and then we're going to say, again, public void, and we're just going to print your balance, which is balance. Okay, so every time we make a transaction, we're gonna call then show balance, right? And okay, very good. So when we make these transactions, it'll automatically print those right there, balance. Okay, very good. So if we wanted to make this a little bit more clear, we might want to say inside our pay bill, we might just want to say sysout paying bill, paying bill, and then we'll concatenate amount, and then also we'd want to say something like sysout making deposit, and then of course we're going to concatenate that amount as well. So there we go, make a deposit, there we go. Okay, so it looks like this is working fine. Let's see here. Make deposit, balance, make deposit. Okay, so these numbers are in fact adding up. Okay, very good. So the last thing we might want to do, let me maximize this here. We have our balance, we have our social security number, we have our name, etc. Let's say something like we have a so public void accrue interest. Okay, so say this is some bank account and we have our interest rate. So again, we might have some interface here, right, that would have, in fact, let's actually create an interface. So if we create an interface, which we can do in a new interface, I'm going to call this iInterest. Okay. Now in this interface, I'm going to have a public. This is going to be public double rate equals, we'll say 4.5, and then we're going to have a public void accrue. Okay, so public void accrue. So in other words, if I implement this bank account class implements iInterest, then we need to I'm going to delete this method. I'm going to hover over this red arrow. It'll say we need to implement this accrue. Now that accrue, we can then say our balance equals balance times rate, right? And that rate is going to come from our interface, which we define right here, right? So this is some other class, right, that we're implementing, say someone from obviously New York or some centralized bank system is setting the interest rate that we're going to access. Because we are implementing that interface, we don't need to define the rate, right? We're going to grab that from somewhere else. Of course, we need to divide this rate by 100 to make it into an interest rate. 100, and then we need to actually add 1 to it. There we go. Okay, so now we can call this accrue method, accrue, and when we accrue, after we accrue, once again, we're going to call show balance. Okay, now let's run this, and there we go. So let's see if there's anything else we can need to do to enhance this. We can also, I guess, we can do the public void toString, right? So toString is an inherited method from the object, and so we're going to override that. And if we call the toString, then let's see, why is that void? Oh, this should be, we're returning a string, toString. We're going to return, let's see, we're going to return, we're going to say name, then we're going to concatenate, and then we're going to say, actually let's put all this inside square brackets here, /n, and then we're going to say, after name we're going to do account number, concatenate account number, close off that item, /n, and let's do routing number, and once again we will add that, close off that with a square bracket, and let's do the balance. So we'll do the balance. There we go. And then we're going to do balance. Once again, close that off there. Okay, so we're overriding the toString, and because the toString returns something, we actually need to have this be the same type, which is string. Okay, now let's call the account1.toString. Now we run this, and let's see, that did not do what we were hoping for. We called the toString. Oh, we need to print that. Oops. So we need to print our sysout. We need to print then the toString. There we go. There we go. Name, account number, routing number, and show balance. So that's a more complete version of the bank account application that we did kind of in pieces and bits and parts as I was explaining things. But this is a more thorough as we were working through the entire thing line by line, item by item. So we used access modifiers, we used encapsulation, we used constructors, we used getters and setters, we used interfaces, inheritance, overriding. So we used a lot of object-oriented programming principles here. Of course, abstraction is when we're getting the actual specific methods. So we pretty much used every object-oriented programming concept here in a fairly short amount of time. But if you're new to this, obviously rewatch the video, because this covers quite a bit in terms of if you get this, you can kind of apply the same principles to all kinds of projects.